And Sachdeva. I think this is sometime like in summer morning and it's going to be noon very soon. So my talk today is about trusting your software, your supply chain, but being, cautious about it and how to apply zero trust security principles in your overall supply chain and CI/CD pipelines as such. Although a brief intro was done, but just a small thing, I work at Capgemini. I co-founded Kenny XCR Java user group a few years back. I blog on Medium. I've authored 2 books and a video course some time back, and these are my credentials. Want to connect later. So, what I'm going to do, whatever time I have today, is like talk about, just introduce a little bit of what is the supply chain attack surface area, and what is zero trust architecture as such, the core principles of it, and key pillars behind it, how we can handle that as part of CI/CD planning, and essentially how we can use policies to make sure that our software is more hardened. It's obviously a very big topic. I'll try to see, how briefly and I can cover it. And then a couple of metrics which I can introduce, you can track and make sure that your software supply chain is actually safe. So I believe most of you would have heard about this attack. The SolarWinds attack happened a few years back. It was an interesting thing is that the hackers actually, what they did was they did not attack the target system directly. But SolarWinds is a SaaS provider. They had an Orion software. They infected that Orion software actually with malicious third-party softwares. And different organizations, there were hundreds and thousands of users, including US government departments, who were using them. Their systems got impacted. So then actually, ultimately, boomerang, and it became kind of a volcanic eruption in a sense, like it went ahead and freaking more and more deliters. Although this was fixed, but the point is that the end users were trusting SolarWinds, that whatever they are getting from SolarWinds is safe. But actually, that was malicious. So that's the idea behind zero trust, that rather than going for perimeter-based security checks, just like our kings had earlier, boats on the forts long time back, we should go for more of like a hotel key approach. Like these days, if you go to a hotel, you get a key and you can only go to your floor, and then you need that key to actually go to the lift, etc. also. So that kind of security we need to embed into our softwares also. So one thing to actually be happy about that is that the market is growing at a very healthy CAGR of 16%. And eventually, some research firm has predicted by 2035, it's going to be $183 billion. So it's good for everybody, including even me, that will have more work this domain also. So this is a very difficult CI/CD pipeline. I'll not explain it because I know each one of you know by this by heart. But just to say that these are some typical, code, build, deploy, and run. These are, you can say, some of the key phases. Interestingly, you think about, like, say, a cold freeze unit in physical world, for example, for transporting food or fruits, for example. So we call it supply chain because from the time, let's say, wheat comes out of the farm and it goes to a store nearby, and then to people like you and me, with the entire supply chain logistics behind it. Just like we should think about our own software delivery practices like a supply chain. Like software is what we produce and what we deliver. Like we are not quote unquote farmers as such, but we are just creating and delivering software. This is our supply chain. And it has a lot of, I would say, vulnerability. It can be vulnerable in a lot of different kind of attacks as such in various pieces, various parts. So it actually starts from us, the developers, or the people who are building the software, because these days, we use a lot of third-party software, open source software. Even if I have to, let's say, write Hello World in, let's say, Spring Boot, for example, there will be, God knows, 10, 20, 30 different libraries I'll be using it. So we have to be very cautious what kind of softwares and third-party, etc. we are using as such. Hackers are becoming smarter day by day. Like they're even releasing, let's say, they pick up a popular, let's say, software like Django, and then they can do a little bit spelling change like DAGANG or tight, which is like typo squatting, so that like can mislead you to downloading that malicious package and using your, within real pipeline. So we have to be cautious about it. Then many other areas are there, like vulnerabilities like branch privilege escalations, and there's another interesting case where for a very popular IDE, a malicious plugin was developed, and people were like kind of misled to download that plugin into their IDs, and then they started building it, and you can imagine what would have happened. So, dependencies in the way we are using IDs also, there's a lot of areas where we have to be cautious. And then when we come in the build phase, even if you're doing using, let's say, one CI runner for all the different kind of activities or jobs, that leaves an area for security vulnerabilities, like low priority, high priority jobs. It's better to have different tunnels, and so that people don't exploit it. And secrets is one thing which probably we should never kind of expose and use some secret management systems. I think you can see that there are similar such areas where you can think about they can do vulnerabilities. Now there's a lot of talk about AI as such, AI, Gen AI, Agentic AI, and people have been into Bharat Mandapam also recently. Although my talk isn't talking about AI, but the thing is that if you are using Agentic AI, now hackers are becoming smarter. Like we think we are smart, they are also becoming smart. So we know that most of the LLMs, right, what they do, they train on open source repositories because they will not train on enterprise code because of proprietary and license and those kind of things. Nowadays, hackers are putting some malicious code in very popular open source repos. So let's say when a Sam Altman picks up a popular open source repo, some data to train his LLMs, so automatically those malicious pieces of code go into the trained model, and then you use that to generate code or configuration or whatever the case may be. So there's a backdoor actually in your software, which they can then actually attack. So so these avenues for hacks are increasing day by day. Okay, a very formal definition. I'll not spend too much time on it, but the point is that standard bodies are also thinking about it. NIST has come out with some standard definitions like zero trust is a collection of concepts and ideas for minimizing uncertainty, enforcing accuracy, etc. And then in order to build upon that concept, we have zero trust architecture, cybersecurity plan that utilizes the zero trust concepts and encompasses component relationships, work for garnering access policies. Very heavy duty words. Let's not think too much about it. I'll try to simplify it later onwards. But the idea is to make sure that we don't trust anybody and execute trust, but we verify everybody at each and every stage. So, a lot of enterprises are thinking about it, and as per Gartner, one of the famous research organizations, 50% organizations will adopt some kind of zero trust governance model. So, all right. So, we come to the grunts of the zero trust architecture as such. This has been given by US Department of Defense. Most of you would know that Department of Defense has done phenomenal contribution in actually software engineering, computer science, and many of these kind of standards. So it is more of like you can say a puzzle where we have some core principles around the central pillar, which is data pillar. So the idea is how we can use these key pillars to make sure that the data remains secure and it is not used by malicious actors as such. So starting from your devices, etc., where they should be continuously monitored for any kind of gaps. So we are living in a hyper connected world where mobile devices are always there on, and we talk about IoTs, etc. So there's a SIM card probably in each and every place in a smart factory. So then again, that means you have to continuously verify all those areas. Your workloads, who is actually running our job or workload, etc., what kind of permission they have, what kind of resources they have to use, etc. That is again important. Visibility and analytics. So there's a sponsor I met today here. They have a company like they are building Dedo POPs, like using agentic AI. So the permissions or rights to users, try to give short-lived permissions, use role-based access control, multi-factor authentication, those kind of things, so that we know that users are only able to access whatever they require to access. We don't give a carte blanche to users as such. And your overall environment network, again, make sure that it is safe, and automation, orchestration, etc., which helps actually making systems more secure. All in all, which actually all of these pillars will help you in making your data pillar safe and secure. So we move from an implicit trust to explicit trust, whereby earlier we used to say that it's a perimeter security check. Now we are saying that we're going to check for each and every kind of access as such every time you're accessing it. Some of the principles, like we want to be not to trust our others, we want to but verify them also. One of the fundamental thing which is often neglected is the definition of done. So if we can add a couple of checklist items over there, even that can help us. Like whether you have done your, let's say, static tools before the Spring demo, for example. That's a very basic thing. But if you have those checklists, it can help us. Integrate security DevOps. Like generally we talk about DevOps, but actually we should think about more of as DevSecOps. So just like doing your normal tests, etc., security checks and verifications should also be part of your CI/CD pipeline. That's a whole different topic altogether, and we can spend hours talking about it. But just thank you, Pleasure Boy. Have a culture of shared responsibility. Like it should not be just one person's job to make sure that the system is secure. Each and everybody, whether starting from a product manager to an architect, engineers, SRE, everybody is responsible for that, and make sure that they all have their own specific permissions to use whatever they have to use. There's another very famous attack which happened few years back, Log4j attack. Anybody remember that? Yeah, we remember that. Yeah. So again, interesting that this shows again that hackers are very smart, becoming smarter. That they forced users of Log4j through JNDI. They ejected some malicious strings so that people are not people, but applications are basically downloading malicious apps and then running them also on their systems. In my organization also, they were handling products focused for our customer, large US-based enterprise, Fortune 500, and their systems actually went down, and our teams literally worked like around 30 hours or so around the clock to fix and go back to previous version, those kind of things. But the point is that Log4j is something which we think is very basic and we are dependent on it, but we have to still verify it. Don't assume that everything is hunky-dory. So yeah, before you pick any third-party software, you can do some due diligence. Some of the things which you can do, you already would be doing it actually. How popular the software is, how many users there are, what is the number of contributors. One red flag for me is that if people have stopped contributing to a software, an open source, then probably I will not go and use it because it's actually not getting popular. And who are the publishers? What kind of community is there from which you are trying to download the software? And yeah, type spreading again, as I was saying earlier, Django and DAGA and EDO, this is a very interesting trick which people are using. And if there are some high version jumps, that could again be a red flag for you. So be cautious while you're picking up open source software or any third party for that matter. So dependency management, like we all have, I was saying earlier, even for doing Hello World, we are actually using a lot of libraries with third party software, and we are dependent on a lot of things. So how we can make sure that we are managing them properly. So verify their integrity, which will use hashes, digital signatures, package managers. Version training again is important. Like make sure that whatever you're picking, or even if you are releasing some dependencies or open source software, have proper versioning, semantic versioning, and using log files. Better to automate everything rather than doing it sporadically, maybe after every CO sprints or every PI, for example, make it part and parcel of each and every sprint. And yeah, there are quite a few tools available doing dependency management. This NPM, this depend about side from there. You can choose whichever you find for you. So there are many others also actually. All right. So bill of materials. This again concept comes from, let's say, factories, traditional factories, where if you want to even make a, let's say, a motorbike or a cycle or whatever the case may be, each and every nut and each and every screw, smallest piece also, so they create a bill of material to that. This is what we have used in our produce which they are making. Similarly, think about our software also, the analytical thing, a realistic thing. What all things are part of our software? What kind of libraries are used? What are the versions of those softwares? That helps us in also when, let's say, we get some series from industry bodies. There's some hacks. We can actually go ahead and look for vulnerable libraries and actually try to replace them with whatever is the best hardened version of those. Okay. Couple of things which you can, I think it's self-explanatory. Few things which actually you can make part of it, like name of a software, name of author, licenses, versions, open source components, etc. And if those your the software which you're building, what are the dependencies, to make a record of all of that. And there are tools available for that. We don't need to do manually in Excel sheet. You can use these tools to like VB or 3D experiments, for example, and there are others also. All right. So I touched upon the DevSecOps part earlier. So this is a view of the sec within DevSecOps. So like the traditional way we used to do security verification was that after in a release, for example, one or two times there used to be security architecture used to do an audit of the software, and then they used to point out vulnerabilities. People used to fix them, and quite often it led to design and architecture changes also. And nowadays, practically every sprint we're releasing software, and mostly it might be getting deployed to production also. So it's better that we do it in a continuous manner, starting from your design phase itself, like doing threat modeling, making a beta flow diagrams, etc. And use of secure coding guidelines. There are many standards which you can choose from. And software composition analysis, which again is another way of saying SPOM, and static analysis, and then vulnerability testing and pen testing is something you don't need to plan for it separately. Make it a part of your functional testing, make it a part of your integration testing. So during the sprint cycle, when we are doing these various tests, these various activities, so all along the way, even the security checks are also done as part of that. So we talked about CI/CD pipeline actually doing a lot of work for us, but the pipeline can itself become vulnerable, and we need to make sure that even that is hardened enough. So one, of course, is access control. Who can run the pipeline? Who can do admin level work? Who is like a normal user? So we need to make sure that we use techniques like least privilege, and we can probably use OpenID, multi-factor authentication, etc. So yeah, better to use standard stuff like pipeline as code essentially, and version pinning, and don't use dangerous triggers which can elevate privileges. Secrets again is important. There are many techniques of doing it. You can use a KMS, you can use HashiCorp, whatever the case may be. Try to rotate them regularly. And yeah, I mean, keep scanning your code bases regularly for any kind of vulnerabilities, any kind of secrets which are part of your code base, or even your logs, for example. And we can use Salsa framework, for example. It is basically defines different levels of software, third-party software which you're doing everything in your overall system as such. So yeah, These steps can help you in higher your overall supply chain as well. And of course, infra and bit security, better to use short-lived runners and agents rather than long-lived ones. And network isolation also is very important for our servers. We have concept of VPCs in hyperscaler. Similar stuff we should try to do within our on-prem systems also. So another interesting concept again given by NIST is use of policy as code. So what they mean is that we defined policies in terms of who can use and what team, etc. And that should be like defined like code or maybe in a configuration setting, etc. The key part of it is that there's a policy engine which actually uses enterprise guidelines, and it can use external sources to define who and what can use what kind of resources. There's an administrator which can actually control the enablement or the disabling of access of resources. And then there's a enforcement point which actually helps in providing the connection and also terminating when it feels that the access should not be there to a resource. So the idea is to make it configurable. The idea is to have use policy as code as such. So yeah, I just mentioned whether you want to do for infrastructure provisioning or you want to do for access control or cost control. So all of these aspects and even compliances, like many times they have to comply with that's a security standards like NIST or GDPR or HIPAA for medical, etc. So all those you can make sure that you give their access based on the standard compliances only, and that can be done through policy management. I'm rushing the time, but yeah, I think again coming to the point that not only building the supply chain and the software, but actually monitoring that in the runtime is also very important through continuous observation. Nowadays, of course, there are a lot of tools available. There are very agentic capabilities also available these days, which can detect anomalies, which can actually look at your metrics, alarms. In fact, look at metrics and logs, etc. to predict if there's an anomaly just going to happen in the next few cycles, for example, so that you can be ready to take those kind of actions. Look at the logs, etc. Make sure that you can map the context of the events and warnings which are coming so that you can better handle it when the time comes. And real-time analysis is important. Again, macro segmentation in a way that your overall system, you create small segments, define small parameters in the overall system, so that it should not happen that once you get inside the system, once you get inside the outermost perimeter, you are able to access everything around that. And yeah, I mean, just enough access is extremely crucial in a way like people should have access to an extent what is required for them. If it's a normal user, don't give them an admin access. If you need access for one data resource or one data asset, there's no need to give access of all the data assets as such. And then your endpoints have proper protection mechanism for that. Again, a lot of tools are there, like we have Open Telemetry, Istio is pretty standard. EVAF is another thing which you can use for kernel level DL inspection also of your overall system as such. It's important to measure whatever we are doing so that to know whether how successful we are. These are some metrics. I think one or two important ones are like how much of the overall software you're mentioning as part of your SBOM. Maybe you can monitor that also so that you can try to improve upon that and see how much time you take to for dependency risk, policy violation rates, vulnerability age, etc. So these are various metrics which you can see to know that you can monitor to know that how effective you are in terms of hardening the system. So yeah, I mean, the same principles work for whether you're working with cloud or any other software, or also of course for Kubernetes systems also. The same concepts are there, the same pillars which I was talking about earlier, like identity and access, do not have anonymous access or RBAC, etc. And protect your data, essentially use encrypt HCD storage, and make sure that all the communication is using TLS or MTLS for that matter. And segmentation is important. You can have default denial policies to isolate your ports. One of the most easy technique, which is quite common actually, you can use service meshes like Istio, etc. I'm sure you must be normally using it, but continue doing it, because then you can switch the contextual activity to those bonds, so your core pods don't get affected if there's some hack or someone gets in tight to your system. Continuously verify whatever is happening in your system with scans and alerts, etc. And of course, important to protect at runtime also. Don't have privileged containers and don't run non-root containers as such. Some of these aspects, the same aspect you can apply to a typical Kubernetes environment also. So I think a very quick checklist. So identity access management. I mean, whenever you create your overall, configuration and policies, etc., and if you want to make sure that you're doing it right or not, just you can keep in mind this kind of checklist. For data security, for network infra, like micro-segmentation, I would highlight is very important as such. And then again, for monitoring, the most important thing is to continuously monitoring, which is not important. It is not that important, I would say, to monitor everything and to have extensive monitoring. But what is most important is to have it continuously being done and have proper development workflow like dependency management and runtime protection. So I think I just end. I think only one thing is that don't give a carte blanche to everybody. If you want to trust, but verify also as such. And don't have long living permissions or privileges. It's sign everything. And another essential aspect is have policy of support, automator, and continuously observe. I think my time's up. And
Okay, thank you so much for the most valuable insights on zero trust security. And we have a token of gratitude for speaker.
May I take one question, please? Just one.
Okay.
IQ. See, I come from a community where we develop everything on open. Let it hear OSS. I'm very much in favor of open source. I divide my question in two ways. Number one, with your experience, how much open source is being used in serious issues? Number one. Number two, are you not adding certain costs within the application, within the whole environment, when you are not developing on your own, but you are using open source? Because everywhere in your architecture, what you mentioned is there are threat analytics, there are protection and analytics, right from developer till the deployment till the execution. So isn't it a cost to the end user? So what is happening? You are replacing the developer's cost with the trade. So just wanted to know with your experience. My experience is very different. We try to develop our own OS itself if required. Right? We are a non-profit defense community, so the story becomes very different. Okay.
Yeah. So I think there are two parts. One is that you mentioned what the cost part, and the other part was like how frequently or commonly we use open source in typical enterprise applications sector, right? So okay. So I think I'll answer the first part first, that how common open source is being used in typical production enterprise application, etc. I think there's no one rule. People are okay to use it as such. What happens is that what we do is that we have to take, let's say, many times permission from our customers. We say that, this is what we want to use. And many times what also happens is, let's say we were building software for a product of a customer and they wanted to sell that to government organizations in US. So then they have own checklist and they want us to comply with those standards and security practices. Plus, let's say there's a particular version of Python, for example, we were using, but there's a different hardened version of Python which is available, which typically people don't use. And we had to, go forward and start using that. So I think those checks and balances come when you start using that in the enterprises. But as such, people are okay to use open source because to be honest, we can do nothing without open source as such. Even if I want to build microservices on Spring or Spring Boot, I have to use Spring, which is again, open source. I will not build my own orchestration platform as such. Now, the second point was that there's a cost of using open source, etc. I would say, somewhat about open source, I would say if you use any third-party software, there's a, hidden thing behind it. And for that matter, I just mentioned that there were people who were using IDEs and their IDEs actually got corrupted because they downloaded some plugin. So the risk is everywhere. Even at runtime, when you build, let's say, your own software, your own system, everything is homegrown. And you build, maybe your own data center is there, for example. At runtime also, people can try to attack. Maybe the access privileges which you have mentioned, maybe that is, hacked, or maybe everything is kept at one place. Someone is able to figure that out and we can hack your entire system. But again, I think I would rather say from a different perspective is that when we travel, let's say I came a car over here, we know that our roads are not safe. Nowadays, there are people who are making lanes and they're causing most accidents. So there's a risk if I travel my road in my own car, but I can't avoid it. I still have to, do that. It's the same thing here. Like there's no way around open source. The thing is that as a community, like all of us in this room and everywhere outside also, we have to be cautious about it and we have to make sure how secure it can be. And I think if you take it further now, forget even open source. Now we want to use LLMs for everything, agentic AI, etc. People are saying they generate 40% of things ourselves, and I think they have something said there in some panel discussion also that we'll have agentic, processes so that going forward you just click a button and maybe your Kubernetes deployment and rollouts and golden path, etc. Everything will be, automated. Maybe in a year or two, the young engineers, so fresh engineers will come into the industry. Probably they won't even know what is the YAML or a JSON and how do you configuration, how you spin up a pod. It may not be required. So there is no way around it. But we have to be cautious and make sure we do security at all the stages. I hope I been able to answer that.
Okay, thank you so much again.